Hello everyone, this is Shubham Chowdhury and I welcome you again in the 19th video of our YouTube channel. Today is 19th of January and we are discussing this LeetCode medium problem number 9931, minimum falling path sum. First of all, sorry for the late video. So let's discuss this problem. In this problem, they have given a n cross n array of integer matrix and we need to return maximum sum of any failing path through matrix. Falling path through matrix. And what is the falling path? The falling path starts at any element in the first row and chooses the element in the next row that is either directly below or diagonally left or right. Especially the next element from position row column will be row plus 1 and column minus 1 is the first element. Row plus 1 column is the second and the row plus 1 and column plus 1 is the third. So we need to return such value whose sum will whose sum path sum will be minimum, and the path we are following is when we are at 1 we will go only to 5, 6 and 4. When we are at 6 we will go only at 7 and 8. We will not go direct right, we will just go downwards. So here is the example. In the position 1 we will only go to the below element or diagonally left or right. Here they have given either directly below or diagonally left or right. So here we have a sum 1 plus 5 6 plus 7 13 and 1 plus 4 5 and plus 8 13. So we are returning 13 and 13 is the minimum path value. So there are two falling paths with the minimum sum as shown. In the second example, here minus 19 and minus 14 is the path which returns the minimum number of sum. So we are returning that. This is a DP based solution. The approach will be here. The approach will be we will use dynamic programming for this dynamic programming solution. There are two types of dynamic programming approaches. First is top down approach and second is bottom up approach. The bottom up approach also called as tabulation. So we use here tabulation. We will find first element's path value, then next element's path value and add the previous paths to it, minimum previous paths. How? Let's see. We will create a DP array of n cross n size. N matrix is n cross n size, so we will create a DP array of n cross n size. First we will initialize the first row same as matrix. So our DP array's first row will be exactly equal to DP matrix first row, this 2 1 3. Then there are three possibilities here, and this is the general formula we will use, and we will change according to our three and four possibilities. Here the general formula says that the DP of ij, value of DP of ij will be equal to matrix of ij. So if DP of 0 1 DP of 1 comma 1, this index, this five values index, DP of 1 comma 1 will be equal to matrix of 1 comma 1 means 5 plus minimum of DP I plus 1 j minus 1. So I plus 1, okay, we will here we need to use DP of minus 1. Just I make the corrections. So this is the correct formula. We will increment add matrix of ij plus minimum of these three values, and these three values are for 5 we will calculate the minimum value of 2 1 and 3. So 1 is the minimum value, so we will add 5 plus 1 and 6. So at dp of ij, we will update the 6 value from 5. So this is the matrix example, and this is the array, dp array we will get. For the first row, it will be same as dp matrix array. For this, now the three cases here are, if we are at I equals to 0, so I is equals to row and j equals to column. If we are at this row, we will simply insert these values. So after that, if we are at j equals to 0 position, means 2, 6, 7. So column number 0, if we are at this position, we will simply add the, for these 6 element, we will add this 2 and 1 only. We will check minimum value of 2 and 1 only. So our this value dp of I minus 1 and j minus 1 is not there. So we will skip that value. And for j equals to n minus 1 position, if j is if dp of I last position, so we will skip this value dp of I minus 1 and j plus 1. So for 4 we will skip this next element, as we are not getting any element here. So for for this index, we will calculate 6 plus minimum of these two values. So minimum of these two values is 1. 6 plus 1 is 7. So for this index, we will calculate 5 plus minimum of all these three. So 5 plus 1, we will get 6, as 1 is minimum value. Here 4 plus minimum of these two. So 4 plus 1 is 5. Now for the seventh, for this position, we will calculate minimum value through here only, the dp array. We will not calculate through matrix array. So we will calculate 7 plus minimum of these two, 7 and 6. So 6 is the minimum, so 6 plus 7, 13 we are getting here. For 8, we will take minimum of these 3. So 5 is the minimum, so 8 plus 5, 13 we are getting. And here for 9, we are taking minimum of 6 and 5. So 9 plus 5 is equals to 14. And after that, we will return the minimum value of this last row. So here is the approach. Let's code for the solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So first of all, we will create a, so we will declare a size variable. So after that, we will create a dp array. Now iterate through the dp array for int I equals to 0, I less than n, I plus plus.